Okay, so now suppose that we have two functions, f and g, which both have inverse functions. Now we have to show that if we have a function h which is equal to f of g, then the inverse of the function h is just g inverse of f inverse. Oops, I shouldn't write it like this. G inverse of f inverse, right? So we have two functions f and g, and each of these functions individually have their own inverse function. And we have to show that if we have a function h which is equal to f of g, then the inverse of that function is equal to this, right? So now for simplicity, we can let t to be equal to g inverse of f inverse, right? Or this is basically t of x is equal to g inverse of f inverse of x, right? And we also know that h of x is equal to f of g of x, right? So we have these two things given to us, right? And we have to show that if h of x has this form, then t of x is the inverse function of h of x. And if these two functions are inverses of each other, then we should know that h of t of x should be equal to x for all values of x that is in the domain of t, and similarly t of h of x should be also equal to x for all values of x that is in the domain of h, right? So now we can try and find h of t of x, right? We know the function h, and we also have the function t of x. So we have from this, we have f of g of x. Now our input in this case is t of x, right? So we have t of x. Now we know t of x is this, so we can just substitute it into this function. So we have f of g inverse of f inverse of x, right? So now this may seem very confusing, but the thing is that we have a function g here, and side by side we have the g inverse function, right? And we know that a function of its inverse function is just going to be equal to x, right? So similarly, g of g inverse of x is going to be equal to x, and g inverse of g of x will also be equal to x, right? So similarly, we have g of g inverse of f inverse of x, right? So what should this be equal to? In this case, this is our input, right? So we should get our input back. And so g of g inverse of f inverse of x should give us f inverse of x, right? Now we can just substitute it into here, right? So we have h of t of x is equal to f of f inverse of x, right? So once again, we can see that we have f of f inverse of x, right? So this is very obvious. This should just be, right? We know that f of f inverse of x should just give us x, right? So this is just equal to x, right? So we have just found that h of t of x gives us x, right? So this proves that h and t are inverses of each other. Now similarly, we can show this in the other way around, right? We showed h of t of x. We can also show t of h of x, right? So in this case, well, we have this as t of x. We have g inverse of f inverse of x. So we have T of h of x, and this is equal to G inverse of F inverse of x, right? But in this case, x is h of x, so which is just f of g of x, right? So now once again we can apply the similar method. We have an inverse function of f, and we have the function f side by side, and we once again know that f inverse of f of x will be equal to x, right? So this is just g inverse of, so this part will just become g of x, right? We'll just get our input back. So we have g inverse of g of x, and once again we have g inverse of g of x. This should just be equal to x, right? So we can also show that t of h of x is also equal to x, right? So we have shown that the functions t and h are inverses of each other, right? So if h is equal to f of g of x, then similarly h inverse of x is equal to t of x, which is equal to g inverse of f inverse of x, right? Right, so now we can take a look at another example. We're almost done. So let's say we have the function f of x is equal to the absolute value of 5 minus x, right? So we have this function given to us. Now, does this function have an inverse, right? So, well, we can take, let's say we find the value of f when x is equal to 4, right? So let's say f of 4 is equal to 5 minus 4, or the absolute value of 5 minus 4. This is the absolute value of 1, which just gives us 1, right? Now, similarly, we can find the value of f when x is equal to 6, right? So we have f of 6 is equal to the absolute value of 5 minus 6, and this is equal to the absolute value of minus 1. Well, we know that when we take the absolute value of a negative number, we will just get a positive number back. This is equal to 1, right? So what does this tell us? We took two inputs, two different values of x, and yet it gave us the exact same output, right? So what kind of a function is this? It's definitely not a one-to-one function, right? So this is a many-to-one function, right? And that means that this function does not have an inverse. So no inverse function, right? So another quick example, let's say we have f of x is equal to x minus 1 over x minus 2, and we want to find f inverse of 5, right? So once again, we know that f of f inverse of 5 should just give us 5, right? So we can let y to be equal to f inverse of 5, and so then we can write this as f of y is equal to 5, right? So now what is f of y? F of y is equal to y minus 1, so we're just substituting y into this function. So we have y minus 1 over y minus 2, and this is equal to 5, right? Once again, we multiply both sides by y minus 2. We have 5 times y minus 2, right? And this gives us, right, we have 5y minus 10. So we have for y is equal to 9. So divide both sides by 4, we get y is equal to 9 by 4. Right? So we know that f inverse of 5 is actually 9 by 4. And we can check this ourselves. So if we take 9 by 4 to be our input into the function f, so if we have f of 9 by 4, we can show, well, we can show that 9 by 4 minus 1 is divided by 9 by 4 minus 2, right? And this is just 9 by minus 4 over 4, 9 by 9 minus 8 over 4, right? This just gives us 5 divided by 4 times 4 divided by 1, right? The 4's cancel out and we get 5, right? So that shows that f of 9 by 4 is equal to 5 and f inverse of 5 is equal to 9 by 4. Right. So that's about it for the topic of inverse functions. So throughout this whole chapter of functions, we have looked at the definition of a function. So once again, if I want to summarize, a function just gives us a single input, or it gives us a single output for each input. So a function, it just gives us single output for each input, right? So that is the definition of a function, right? And the domain of a function is just is a set of all possible inputs, and similarly the range is just the set of all possible outputs, right? Now we've also taken a look at how to graph some functions, and we can show whether the graph of something is that of a function or not by something called the vertical line test, right? So if we're given a graph of something, some sort of equation, right, all we can do is just, let's say we have the graph of a straight line, we can just draw some vertical lines at each values of x on the graph, right? And if we see that the graph gets intersected by the straight line only once, then this is the graph of a function, right? Now, if the vertical line intersects the graph at more than one point, then that graph is not of a function, because that would mean that for one value of x, we will get multiple outputs, right? And we've also taken a look at some graph transformation rules. So we know that if we have a function y is equal to f of x, right? And if we add some constant to our function, then we know that the graph of this function will be shifted upwards by c units if c is positive, right? So if we have a graph of a parabola like this, and if we add c units to our function, and c happens to be positive, then the graph will just be shifted upwards by c units. So this will be c units. And similarly, if c is less than 0, then the graph will be shifted downwards by c units, right? And instead, if we added c units to our variable x inside our function, then in this case, there will be a horizontal shift. Instead of a vertical shift, we will have a horizontal shift. And if c is positive, then the graph, so if we started off with this graph and we added a positive c unit to our x variable, then the graph of the function will be shifted to the left by c units, right? So instead we will have something like this, right? So this is a shift by c units. And similarly, if c is less than 0, then we will have a shift horizontally of this graph to the right, and we will have a graph that results like this. So this is a c unit shift to the right, and if we had y is equal to minus f of x, then what do? This is just a reflection of the graph along the x-axis. So if I have a graph like this, I'm just reflecting the graph along the x-axis. So this will be the graph of minus f of x. If this is the graph of f of x, right? And instead, if we had a function f of x and we wanted to graph f of minus x, then in this case, we're reflecting the graph along the y-axis, right? So we just reflect this graph along the y-axis. So this will be the graph of f of minus x. And instead, if we have our function being multiplied by a factor of a, then in this case, the graph gets scaled vertically by a factor of a, right? So if we have a point on this graph that is, say, 1 by 2, then we're just multiplying the y-coordinate by the factor a, right? So this point will become 1 by 2a. And similarly, if we had y is equal to f of a times x, right, then we're scaling the graph. We're scaling graph of y is equal to f of x horizontally, by a factor of 1 by a. So in the previous case for a times f of x, we were scaling the graph vertically by a factor of a, but in this case it's by a factor of 1 by a. Right, so if we had a point, so let's say this is the graph of f of x and this has a point 2, 4, right? And now I want to graph f of 2x, right? Then what happens to this point? Since I'm scaling horizontally by a factor of 1 by a, so I'm scaling in this case by a factor of half, right? So I multiply the x-coordinate by half. So now I have a graph that looks like this. So each of these points, the x-coordinates get scaled by a factor of half, right? So the new point will be 1, 4. And finally, we looked at composition of functions, right? So this is just basically when we have one function, g, as an input into another function, f. So in this case, if we consider g to be inside the function of f, then we would have f of g of x, right? So for some value of x that is in the domain of g, we will get the output g of x, and then we will consider this output as an input into the function f, right? And this will be the composition of these two functions, f and g, right? And in this case, if we have a function and its inverse function, then we know that f of f inverse of x should be equal to x, and similarly f inverse of f of x should be equal to x, right? And we know that only one-to-one functions have an inverse function. Many-to-one functions do not have an inverse function. Right, so that is all for the topic of functions.